Hello, everybody. Welcome to your lecture from section 3.2, where we're going to talk about the product and the quotient rule. The product rule is what we do when we have more than one function multiplied together that we can't split them up. For example, let's say I had 3x squared times tangent of x. I have to use the product rule there. Now, if I had something like this, if I had x plus 1 times x plus 3, I can find this derivative using the product rule, but actually it would be a little bit easier if I just FOILed this out and then took the derivative of this function. So for something like this, I might not want to use the product rule. But for something like the first one, I have to use the product rule. So imagine that I have two functions, f of x and g of x, and I need to find their derivative. I'm going to use this formula. So basically, I'm going to take the first function and I'm going to multiply it by the derivative of the second function. And then I'm going to add that to the derivative of the first function times the second function. So let's find this derivative of h of x. We're going to try it in two ways. First, we're going to multiply and then take the derivative. And then next, we're going to find it using the product rule. So if I'm going to multiply this out, I'm going to take 2x squared times 4x is going to give me 8x cubed. And then I'm going to take 2x squared times 5 is going to give me 10x squared. Now I'm going to multiply out the negative 3x. So by 4x will give me negative 12x squared, and negative 3x times positive 5 will give me negative 15x. If I simplify that, I'm going to end up with 8x cubed minus 2x squared minus 15x. And if I want to take the derivative of that function, I'm just going to do it one term at a time. So for 8x cubed, I'm going to take the 3 times 8, which gives me 24. I'm going to leave the x alone and reduce the power of 3 by 1. So I get 24x squared. Then for the next term, I've got the power of 2. I'm going to multiply that by the negative 2, so that's going to give me a negative 4. Keep the power of x, and then the 2 is reduced by 1, so I get x to the 1. For the next term, I'm going to take the derivative of 15x, and the power of 1 multiplies by the negative 15, and I just get negative 15. So that's my derivative of h of x. Next, let's do it using the product rule. So let's consider h of x, where the first function is 2x squared minus 3x, and the second function is 4x plus 5. So think of this as f times g, where this first one is f and the second one is g. If I want to find the derivative of h, I need to do the first times the derivative of the second plus the derivative of the first times the second. So if I'm going to find the derivative of h to the x, I'm going to take my first function, which is f, and that's 2x squared minus 3x. And then I'm going to multiply it by the derivative of 4x plus 5. Well, the derivative of 4x plus 5 is a real quick, easy one. It's just 4, right? So this whole thing, I'm going to cross it out and I'm just going to write 4. Next, remember the product rule has a plus in it. So product plus, product plus. So now I'm going to add the derivative of the first function, and I'm going to multiply that by the second function. Now the derivative of the second function, if I use my power rule, I take the 2 times 2, this is going to give me 4x to the 1 minus 3. And sorry, I wrote my x in there for my first function, but it didn't go through. So that's the derivative. Okay, let's combine terms. Let's see what happens. So here, my first function, I've got 2x squared minus 3x, and I need to multiply that by the derivative of the second, which was 4. Then I'm going to add. The derivative of my first function here is 4x minus 3. And then I'm going to multiply that by the second function, which is 4x plus 5. So for this first one, I'm going to go ahead and distribute out the 4. So I've got 8x squared minus 12x. Here, for this function, I need to multiply that out. So I'm going to get 4x times 4x is 16x squared. And then I've got a positive 20x and a negative 12x, so that's going to give me a positive 8x. And then negative 3 times 5 is going to give me a negative 15. And as long as we combine our like terms, we'll be finished. So h prime of x is going to be, I've got 8x squared and 16x squared, so that's going to give me 24x squared. And then negative 12x and positive 8x is going to give me negative 4x. And then the negative 15 goes along for the ride. And so there's my function. Notice, no matter which way I take the derivative, I will get the same answer. Also notice that for some functions, no formula is a little bit quicker. But for some functions, I can't multiply it out first, and I have to use the product rule. So just keep that in mind. Some functions require the product rule. All right, for this example, let's differentiate the function using the product rule, and then let's find the derivative value at 4. So I'm going to think of this f of t, where the first function is f, and the second function is g. So this f prime of t, think of that as f times g. And then if I need to find that derivative, and I'm feeling weird about calling it f, so actually I'm going to call this one h, so I don't have 2 f's in there. Remember, the derivative for the product rule is the first times the derivative of the second plus the derivative of the first times the second. So let's go ahead and do that. So my first function is the square root of t, but I'm going to write it as t to the 1/2. Next, I need to take the derivative of t minus 1. Next, I'm going to add. Remember, product means plus. I'm going to add the derivative of the first function times the plane Jane of the regular function. And I got a typo over here, by the way. I'm taking the derivative with respect to t. All right, let's go ahead and find those derivatives and combine them. So this first one here, this is just t to the 1/2. That's all set. The derivative of t minus 1, that's just 1. So this whole thing right here, that's just going to be 1. This derivative, remember what we do with the derivative. We take the power and we bring it down, and then we decrease the power by 1. So I'm going to have 1/2 minus 2/2. So this is going to be 1/2 t to the negative 1/2. That's that derivative. And this one here just is as is. This is the t minus 1. So here I'm going to get t to the 1/2 times 1 plus 1/2 times t to the negative 1/2 times t minus 1. In order to simplify, I need to distribute this out. So here I've got my t to the 1/2. That's just going to hang out. It's not doing anything special. And then when I multiply t to the negative 1/2 by t to the 1, I'm just going to add their powers. So this gives me 1/2 t to the 1/2. And then I need to multiply this by negative 1, so I'm going to get negative 1/2 t to the negative 1/2. Now I'm just going to combine like terms. I've got 1, remember this is like an invisible 1 here, 1 t to the 1/2 plus 1/2. This is going to give me 3/2 of t to the 1/2 minus 1/2 t to the negative 1/2. Now this problem was written in root form. Okay, it was written with square roots originally. So when we rewrite this, let's rewrite this as a square root expression. So t to the 1/2 is like saying the square root of t. And then I've got t to the negative 1/2. So that would be my function there. I can write my answer like this, unless I want to write it as one full fraction. And I can do that by multiplying by the LCD, building that up. And the LCD is going to be this 2 square roots of t. If I were to do that, I would have this 3 square roots of t over 2. Let me just write this out. 1 over 2 square root of t. If I need to build up the LCD, I only have to multiply the first one by the square root of t. It's really not bad at all. And then I would end up with 3 times t, because the square root times itself just pops out the inside, minus 1 all over 2 square roots of t. So either one of those answers are acceptable. When we get on into later sections, we do have to write it in this more condensed form. This next rule is the quotient rule. Again, let's color code this. We're going to consider f of x and g of x. And let's consider the fact that both of them are differentiable functions. Now, we use quotient rules for things that are expressed as rational functions. For example, if I had something like the tangent of x and I divided that by 3x plus 1, I have to use the quotient rule. So let's take a look at the quotient rule. It's complicated. okay? It's not just take the derivative of the top and take the derivative of the bottom. It's take the bottom times the derivative of the top and then subtract. Quotient is subtract. And then you take the top times the derivative of the bottom, all divided by the bottom squared. A lot of students really jack this one up. Order matters because of the subtraction here. So make sure that you're keeping your wits about you. There's another way to remember the quotient rule, which I think personally is very helpful. Think of your top function as the high function. Think of your bottom function as the low function. And so the way that we do this is we remember this and we say low d high minus high d low all over the bottom squared we go, right? So low d high minus high d low all over the bottom squared we go. A good way to remember it too is remember it starts with low and it ends at the bottom with low squared. So low d high minus high d low all over the bottom squared we go. And d, this little d right here, of course, stands for derivative. All right, let's try a couple. So let's find the derivative of this function. Think of the top function as the high and the bottom function as the low. And we're going to find the derivative h prime of u using the quotient formula. So we're going to start off with low d high. So the low is the 1 plus u squared. The d high, sorry, not with respect to x, the d high is the derivative of the top. And then don't forget the minus, quotient minus. It's product plus quotient minus. So now we're going to subtract and we're going to do high d low. So we take the high function and multiply it by the derivative of the low function. And then the last part is the low squared. So I take my low function and I square it. And by the way, just leave that thing written as squared. You really don't have to multiply it out. Sometimes if we leave it unmultiplied, we actually get some cool stuff to cancel. So, all right, I'm just going to take the derivatives here real quick. This derivative of 1 minus u squared, the 2 comes down, multiplies by the negative. So this derivative right here becomes negative 2u. And then this derivative right here becomes 2u. Because remember, the derivatives of 1 is just, those are constants. That's just going to end up as 0. So now let's put that together. I've got my first binomial, 1 plus u squared. And then I've got this derivative here, negative 2u, and then minus. And then I've got my next binomial of 1 minus u squared. And then I've got my next derivative of 2u. And that's all over 1 plus u squared squared. Now I need to simplify the top. So I'm going to distribute out this negative 2u. And then I'm going to do a little trick here because I need to distribute out the negative and I need to distribute out the 2u. So I'm going to do that in one fell swoop. Okay. I'm going to turn that 2u into a negative 2u, and that changes this minus to plus, and then it's a little bit easier to do. So in the top, I'm going to have negative 2u and minus 2u cubed. Then I'm going to have negative 2u plus 2u cubed all over 1 plus u squared to the power of 2. Notice I can get some things to cancel. My negative 2u cubed and my positive 2u cubed will cancel each other out. And then I'm basically done. My derivative ends up being negative 4u on the top, and then this 1 plus u squared to the power of 2 on the bottom. And that's how I find the derivative using the quotient rule. Remember, whenever you do something with derivatives that has a numerator and a denominator, you have to use the quotient rule. Let's do a couple of examples using just some numerical things. So let's lay down the rules. I've got f of 3 is 4, g of 3 is 2, f prime of 3 is negative 6, and g prime of 3 is 5. And let's find the following numbers. And actually, I'm going to color code those bad boys super duper quick here. So the first one's green, next one's blue, one after that's going to be orange. And let's go ahead and use purple. And I hope you can see the difference between these. All right, and I'm going to do these examples in yellow. All right, so I have f plus g prime of 3. Well, remember for adding, we don't have to do anything funky. We just do f prime of 3, and we're going to add to that g prime of 3. We don't have to do any special rules. So f prime of 3 is this orange function, so that's going to be negative 6. G prime of 3 is this purple function, so we're going to add 5 to that. So the answer to this one is going to be negative 1. For this next function, notice we have a product. We've got f times g. So f times g prime of 3, we're going to use the product rule. So that's going to be the first. So that's going to be the first times the derivative of the second plus the derivative of the first times the second. So f of 3, that gives me 4. So that's what I'm going to use for that. For g prime of 3, that's going to give me 5. F prime of 3, that's negative 6. And g of 3 is going to give me 2. So this gives me 20 plus a negative 12. And I end up finding 8 as that derivative. The next one, we got to use the quotient rule. All right, remember, low d high minus high d low, all over the bottom squared we go. So my low is g of 3 times my low d high, so f prime of 3. And it's minus, because it's the quotient rule and we subtract. So minus the high, the regular, so f of 3, times d low, which is the derivative of the bottom one. And then this is all over the low squared. So g of 3 is going to give me 2. This first one here, g of 3 is going to give me 2. F prime of 3 is going to give me -6. I'm going to multiply those together. And then I'm going to subtract because it's the quotient rule. And f of 3 is going to give me 4. And g prime of 3 is going to give me 5. And then g of 3, we'll use that again. That's going to give me 2. So I'm going to square the 2. So I'm going to end up with -12 minus 20 all over 4. And that's going to give me what? -32 over 4? Which ends up being 8. How about a -8? Good. All right, so this is the quotient rule. Keep in mind that the quotient rule has f minus g in the bottom. So when we're finding the derivative, the low is f minus g. So we start off with low d high. So we need to do low, which is the f of 3 minus g of 3, times the derivative of the high, which is f prime of 3. So the low is f of 3 minus g of 3, times the derivative of the high, which is f prime of 3, and then minus the high, which is f of 3 again, times the derivative of the low. Now, the derivative of a subtraction is just subtracting the derivative. So this would be f prime of 3 minus g prime of 3. All over the low squared. All right, so let's plug those values in. F of 3 is going to give me 4. G of 3 is going to give me 2. And then I need to multiply that by the derivative of f of 3. And that's going to give me -6. And then I'm going to subtract from that f of 3, which is 4. And then f prime of 3, which is the -6. I'm going to subtract from that the g prime of 3, which is 5. And then I'm done with that top portion. And then in the bottom, I'm going to take f of 3, which is 4. And I'm going to subtract from that g of 3, which is 2. And then I'm going to square it. So 4 minus 2 is 2. 2 times -6 is -12, minus -6 minus 5 is -11. -11 times 4 is -44. And then 4 minus 2 is 2, and 2 squared is 4. So let's do -12 plus 44. And that's going to give us 32 all over 4. And that gives us +8. Huh. These are long, but they definitely help you figure out if you know your product and quotient rules. Don't forget, product is plus, quotient is subtract, and the order matters in the subtraction. Low d high minus high d low, all over the bottom squared we go. Aren't you glad we have a limerick for that? Okay, carry on. Good luck in section 3.1. point.